Today we're going to finish section 3.3. The first thing I want us to talk about is what a tautology is. A tautology is a statement that is true regardless of the truth values of the component statements. And you can recognize this because you will have a truth table. The final column has all T's in it. So the final column of a truth table has all T's. And we're going to construct a couple more truth tables in the last part of this section, and we're going to see if any of them are in fact tautologies. So the first one that we see here is a truth statement. You notice we only have two statements, P and Q. Tilde P is a statement that is exactly dependent upon what P is, so it doesn't count when we're counting individually different statements. So I have P, I have Q, I have tilde P, and then inside those parentheses you'll see that I have tilde P arrow Q. And then if we call this statement right here number 1, we can take a look at saying that number 1 would imply Q. And we're going to create this truth table. So as we've talked about in class several times, P is TTFF, Q is TFTF, tilde P would be the opposite of column P, so it would be FFTT. And then we take the tilde P column that we just created. Let's try that again. There we go. And we do an arrow back to the Q column. We'll go backwards to this column and we'll highlight it in a different color. So we'll go backwards from the kind of orangish shading over to the red. So we have a false implies true, which is true. We did that last time. False implies false is also true. True implies true is true, but the last one, true implies false, is false. It's the only time we have a false statement on an implication, which is T arrow F. Now we're going to take this new column that we just created, and we will call it blue. We'll do it in blue, and we're going to draw an arrow back to the same column Q that I just did. And let's do this in a different color as well. So we'll go back to this same column Q. So now we start out T implies T, that's true. T implies F, that's false. T implies T is true, and F implies F is true. But you notice that not all of them are true statements, so this is not a tautology. Let's try another one. What you should notice different about this one is that there are in fact three different statements. I have P, I have Q, and I have R. So I'm going to have a much larger truth table on this one. We have P. Do a column for Q, a column for R, and I need a column for tilde Q. P, Q, R, and then tilde Q. And then looking inside my parentheses, I have P and tilde Q. And then if we label this as number 1, we can take the R and do an arrow to the number 1. And that should complete our truth table for us. So, we talked about last time, we will have 8 rows here because we have 3 individually different statements, P, Q, and R. P has 4 T's and then 4 F's. Q has 2 T's, 2 F's, 2 T's, 2 F's, And then R oscillates. T, F, T, F, T, F, T, F. Tilde Q will be the exact opposite of column Q, which means we'll go F, F, T, T, F, F, T, T. Then we're going to take the P column and the tilde Q column, the blue and the green, and we're going to combine them with the statement AND. So an AND statement is only true if both statements are true. So the first column, or the first row in this column, we'll see TF, and that's false. Another TF is false. I have TT, which is true. Another TT is true. And then on all of the last ones, they're false, because P is false. Now we're going to take the R column and the column that we just created, and we're going to do an arrow from R to P and tilde Q. So this is an implication. An implication is true when it's either true, true, false, false, or false, true. So this first one is true, false, that's false. The second one is false, false, that's true. The third one's true, true, which is true. The fourth one's false, true, which is true. And I have true, false is false. False, false is true. True, false is false. And false, false is true. And again, is it a tautology? Not a tautology, because we don't have only true statements at the end. It's not all T's. All right, so just like we talked about negations when we did De Morgan's laws of and statements and or statements, we also have a negation statement for P arrow Q. And a negation for P arrow Q actually is an and statement. It's P and tilde Q. So going back to our conversation from the last class period, we had talked about the idea of if I had given you a rule, if you will, in the first day of class, that if your professor shows up, then you will have class. Okay, so that would be my implication. So the negation of that happening, the exact opposite would be that the professor shows up and you do not have class, which is exactly the professor showing up, P, and the Q being having class, so tilde Q being not having class. And both those things happening at the same time would be a negation of your first statement. So we're going to write a negation of this statement now. It says if Ella reaches that note. So the statement is that Ella reaches that note. Okay? So notice that's P. The if is not a part of P. It's a part of the implication. It's part of the connective. So I'm going to write down P again, which is Ella reaches that note. Now I know on this one you don't actually see the then, but the then of course is right here. So before we get to the then, after we get to the then, we have the second statement, she will shatter the glass. So my implication, notice up above, when I do the negation, I have an and connective, so I'm going to put and here. And then tilde Q, so if she will shatter the glass is Q, then tilde Q would be she will not shatter the glass, or she does not shatter the glass, perhaps. We'll write it the way I said first. She will not shatter the glass. And that would be the negation of the statement that's listed. Now we also have the idea of taking a conditional and then writing it as an or statement. So the conditional written as an or statement is tilde P or Q. So we negate the first part and we leave the second part the same. So if we take the following statement and write it as a negation, it says, if she doesn't, then he will. Well, again, the if is not a part of the statement. She doesn't is. So I need the negation of she doesn't, which would be she does. And then, okay, let's try that again. She does, that's better. And then you notice I've got an or, because I've got the or connected between them, and then the second part stays the same, and it's he will. Right, so she does show up, or we will have class. Right, these would be the connective. This is how you would do that. that's not a good example, but she does or he will would be the values for this particular one. And that's the end of this particular lesson.